In this video, we are going to discuss the second formal definition of the parabola. We have the locus definition. Okay, so what does the locus definition states? So the locus definition states that the parabola is defined as the locus of a point which moves so that if it is always the same distance from a fixed point, okay, so the fixed point is called the focus, and a given line called the directrix. So what does it mean? Okay, so to simplify, let's try to observe first this graph here. Okay, so we have the focus, we have the point P, and we have the directrix here, the green line, and the parabola, the blue. Okay, and we have the vertex. Okay, so the locus definition refers to the distance, actually the d here. So look at here, the d here. Okay, so whenever this distance from the focus, so this is the focus, here. Whenever the distance from the focus to our P and from our P to our directrix, so take note, this is the directrix. Okay, take note also that the distance of the directrix to our point in the parabola is always, or it creates a perpendicular segment. So perpendicular meaning 90 degrees. Okay, so the distance between, let's just name it FP. Okay, F from our focus to our P, and the distance from our P to our directrix. So let's name the point here in the directrix, this one here, the moving point here. Okay, if they are equal, we create or form a parabola. Okay, so again, if our distance from F to P and P to D, these two segments are equal, okay, two segments are equal, we create a parabola. So this is how the locus definition works. Okay, so something to take note about the locus definition, we have the concept of eccentricity. So maybe you have heard this already in the prior videos or from the prior lessons. So eccentricity, when we talk about eccentricity, okay, this does not mean strange. Okay, so eccentricity here is actually a ratio, and it's the ratio of the distance from any point on the conic section. So in our case, the conic section here is the parabola, to its focus. So the point here is P, of course, and to our focus F, and the perpendicular distance from the point P to the nearest directrix, which is the point in the directrix D. Okay, so it's a ratio. So if it's a ratio, it is actually a fraction. Okay, so it uses the operation division. Okay, so it says that the ratio of this distance FP, so ratio is over PD. Okay, this will give us the eccentricity E. Okay, so if we divide FP and PD, or FP over PD, it gives us the eccentricity E. Okay, so observe that in our parabola, it states that FP, okay, so let's go back to our here. Okay, so it states that our FP is equal to our PD. Okay, so what happens if we divide these two? Okay, divide this FP and PD. What do you think will happen? Okay, so obviously, since they are equal, or in other words, lengths are equidistant, this gives us a ratio of 1 because they're the same. So for example, if the distance is 2, and we said that FP is 2, so PD is also 2. So 2 divided by 2, the ratio is 1. The answer is 1. Hence, we must remember that the eccentricity of the parabola is always 1. Again, no matter what or how you try to define the distance from the focus to the point in the parabola, their eccentricity will always be 1 because they are equidistant. FP and PD are equidistant. Okay, so it's now your turn to answer. Okay, and try to think also. It's important to think. So in your own words, how do you define a parabola? Again, in your own words, how do you define a parabola? You may use some concepts, so using the two definitions, but as much as possible, try to define it in your own words. So answer it after this video. So in the next video, we are going to discuss the elements of the parabola. See you there.